There are perfect things that create pattern, equal to both sides, and something ruins it.
Annoying, right? But what if I tell you that not all symmetric things are beautiful, even though it is not totally equal to both sides?
For example, our faces. Our face that show so much emotion and expression. We know how we look like, we know every corner of our face, and we notice that sometimes our right eye is bigger than the left eye, or we have a uneven face shape. But despite all of that, we still find that our face is beautiful.
Aside from our faces, think of our whole body. Every part of our body parts has its own pairs from eyes, ears, arms, legs, and even our internal organs, like lungs and kidneys. But still, there are organs or parts of our body that still don't have pair, right? Like nose, mouth, and internal organs like heart, liver, and the whole digestive system. Even though it's not perfectly proportional, just like our faces, we still find it beautiful on the way how organs function perfectly.
So from the word symmetry, equal and proportional and patterns, we want to share knowledge about symmetry breaking.
What is symmetry and its different kinds and its examples?
And the principle that makes things break, and the correction of symmetry breaking in mathematics.
Hello guys! So today, we're going to discuss what symmetry is. And later on, you may find how prevalent symmetry is in our nature. So, symmetry is a mathematical concept as well an aesthetic one, and it allows you to classify different types of regular pattern, and it distinguishes the difference between them. Are you ready? Let's find out!
So as you can see, this is an example of symmetry. So these are another example of symmetry.
Bilateral symmetry means that if you reflect the left half in the mirror, then you obtain the right half. Reflection is a mathematical concept, not a shape, number, or a formula. It is a transformation, the rule of moving things around. So as you can see, this is an example of reflection and also an example of bilateral symmetry. So this is another example because we can still see a reflection through the wet surface of the road.
There are many possible transformations, but most are not symmetries. So to relate these halves correctly, the mirror must be placed on the symmetry axis. Then, so this is me, this is the mirror, and this is my reflection. So, reflection then leaves human form invariant, meaning my appearance did not change. So, that is the precise mathematical characterization of bilateral symmetry. Now, let's move on to different kinds of symmetry.
First is the reflection. This is an example of a reflection. If you take an object in the plane, pick it up and flip it over onto its back, you get the same effect if you reflected it in a suitable mirror, that is reflection.
So, hello guys. So, it's your boy Raymond. So, let's move on into the second type of symmetry, which is the rotational one. So, here I am on the rooftop of my dome with a really good view, as you can see. Okay, so, and the perfect example of a rotational symmetry is the flower. You see this one? Right. So, in order for us to rotate an object in the plane, we must find its center and rotate that object into that center. So, we found its center, right? So a wheel turns about its hub. So if I do it in the flower, see, nothing will change, and it will just look exactly the same no matter what. So more importantly, we can rotate objects through different angles but with the same axis. So let me repeat it again. So nothing's changed. It just look exactly the same. So that's all. I'm out.
Lastly, translations are the transformations that slides object along without rotating them. And the best object that describe it is a tiled bathroom wall. So let's go. I'm going to show you our tiled bathroom wall. As you can see, this is our tiled bathroom wall. If you take a tile and slide it horizontally, just the right distance, it will fit on the top of a neighboring tile. You can create a combination and other patterns as long as it fits perfectly to each other.
But if you're wondering where do of natural patterns come from the symmetry, let's find some examples. As you can see, if you toss a rock in the pond, we see pattern, ripples, circular waves that moving upward away from the point of impact at the pebble. It allows us to classify different types of regular pattern and distinguish between them.
The other example could be the tiniest or the biggest, just like chemical reaction, methane molecule, benzone, centrosome, viruses, and even the developing frog embryo, volcano, and even the galaxy. It's amazing, right?
Symmetry breaking is just such a principle. However, in order for a symmetry to break, it has to be there to start with. For example, the symmetry in pan where the rings within is forming but the band is very extensive to the point that surface is being equivalent to every part that we don't recognize it as a pattern. That's why we viewed it as a bland uniformity and where the systems happen to be interchangeable or replaceable. We can also say that it's the nation's default option. To be precise, our nature is symmetric because everything is equal at some point, just like the space between the time, matter, and many more along with the laws that govern them. If we're going to think about more symmetry breaking, it's just mind-blowing. But why does it occur in patterns? Why not in a structureless mess in which all symmetries are broken, or importantly, the symmetries that lying around us break unwillingly because they have a seldom reason to break at all. That's why a lot of it survives even though some of it are broken. They are still present but in less symmetric state or in a sense that serves as a potential rather than the actual form of it.
So, the principle of symmetry breaking do not just works for sand dunes. It could be in a muddy water that had been frozen, fluid that might be a liquid crystal, and even the pattern of developing animal.
Mathematics of symmetry breaking describes of animal or the redeveloped animals.
So, here are some examples of living systems and non-living systems have numerous patterns, which is explained by symmetry breaking, and it is the process of symmetry formation and reproduction is life itself. Transverse dunes are comparable to the tiger or zebra, and the most striking rotational symmetries in the living world transcend beyond form into activity and not only symmetrical patterns of locomotion.
Everything is beautiful, from the faces, nature, leaves, flowers, and other things that it is stated. It doesn't matter if it's symmetrical or not, but we are so lucky to have this amazing world and we should enjoy it and continue to be amazed. So, we hope you learned something from this video and we'll see you again next time!